12 years ago, I performed a series of remote tele-robotic surgery operating on patients in a remote city in northern Canada as a means of demonstrating that using robotics and telecommunication, you can provide surgical care to patients from a distance. It was a series of quite complex operations on the stomach and the colon and spleen. During some of the first series of surgeries, we had representatives from the NASA and Kennedy Space Agency who, after observing a couple of the surgeries, put a challenge to me: can you do this in such a remote location when there are no other, it's not a hospital in there? And they offered the Aquarius for a series of NEMO missions, which was an underwater habitat very much similar to the International Space Station, where many of the astronauts, including Katie Coleman, who had flown in space, were being trained for the next series of trips up to the space station. And we did a series of experiments to see how far can we stretch the limit of telesurgery, and we recognized beyond a certain point of time delay, as you would experience with International Space Station, a moon base, or a Mars mission, you are going to require some degree of automation and autonomy. And out of those experiments developed a series of plans for developing robotic systems for medical care, which can incorporate some of that automation and autonomy. We've been working with the same company which has made all the Canadarm and the arms, the robotic arms currently on the space station, the Dexter. And so many of the engineering and the software which had gone into developing those arms for NASA was what was used to develop a series of robots which can use imaging modalities to perform various surgical tasks in an automated fashion.
So it's really revolutionized the medical industry.
It can, and in fact the next stage would be to give it autonomy, and that would really revolutionize. But I don't think at the moment that our regulatory sort of bodies are yet ready for that. But definitely automation, which is what its capabilities are, but really the robot is designed to be able to also perform potentially autonomous acts, to make some decisions, as some of the space robotics can already do. So I think it's the next phase in the evolution. From IGAR, it can be adapted to a number of treatments. The first application is for early detection and treatment of suspicious breast lesions in women with high risk of developing breast cancer. These women are expected to have MRI on an annual screening. And unfortunately for MRI, it's so sensitive they can identify a very tiny lesion which may or may not be cancerous, and then these women have to go through multiple biopsies, sometimes even a lumpectomy, to find out whether it's cancerous or not, and it's a long wait. With IGAR, we are able to immediately, inside the bore of the magnet, target the lesion, go in and biopsy, and in future, if appropriate, ablate the lesion. So it really saves a lot of time for the patient, but more importantly also pain and cosmetic, because it's so minimally invasive and so accurate. It reduces the pain, discomfort for the patient, and the better cosmetic result for the women.
So what's next?
Next is actually hopefully getting the system to a commercial end, to sort of this can go into production and actually into impacting patient care. And we have a number of systems for liver, lung, kidney, and prostate cancer, a similar type of designs, which will be the next. And as I said, my dream is to actually get all of these systems into an autonomous mode, to look at how medical robotics can function in an autonomous mode, still not replacing the surgeon or the physician, but being able to take advantage of the capabilities that a robot can bring to healthcare.